Hello and welcome to 5-Minute Math. Today we are looking at the 4th grade concept of decomposing fractions, specifically how we can decompose improper fractions, and we'll do it in 5 minutes or less. So I'm going to draw an improper fraction here. You'll see it also as a mixed number if you really want to, but I'm going to record it as an improper fraction. And I'm going to show how we can decompose it in a multitude of ways, just depending on how we decide to break up our chunks here. So far I've got 2 wholes, or 8/4, and I'm going to go ahead and fill in 3 of these last fourths. So if you want, you can look at this as 2 3/4, or you can count each quarter or each fourth separately, and you get 4, 8, 9, 10, 11. So we have 2 3/4, we have 11/4 or 11/4. Now, how can I break this up into a sum of smaller fractions? Well, one of the simplest ways would be to use the unit fractions. Remember, unit fractions are fractions that have a denominator of 1. So that's the smallest unit you can have within this fraction. So I would simply write 1/4 plus 1/4, and I would do this all the way until I have 11 of them. So I've got 4 so far. Now I've got 6. And so unit fractions is just going to say 1 plus 1 plus 1 plus 1 all the way across. The thing to remember when you're adding fractions, because if you didn't, this would be a crazy answer, you never add the denominators. The denominator stays the same. Whenever you add fractions, you have to have an equal denominator, because you cannot add fractions with unlike denominators. But when you finally get around to adding them, you never add the denominators up. You just keep it the same. Because I'm just adding 1/4, 1/4, 1/4. I'm not making these 8ths and 12ths and 16ths. What you do add are the numerators. So this is one way that I can show this as a sum of the unit fractions. But how else can I do this? Well, as you see here, I've got 4/4 here. And I've got 4/4 here, and then I've got 3/4 here. So one alternate way would be to simply add up the circles that I see. 4/4 plus 4/4 plus 3/4. This would also equal 11/4. Remember, we're not adding the denominator, just the numerator. You can break it up into different chunks. You can take it in chunks of 2. So I can take my 2 and 2, and then I can bring this last one in all together. So I can say 2/4 plus 2/4 plus 2/4 plus 2/4, and then add that last 3/4. So as you can see, you can go on and on about different combinations. At the end of the day, whenever you're adding fractions, your denominator needs to be the same, and when you finally do get around to adding it, you don't add up the denominator, you keep that the same. Let's look at a different example. Now I have 4 rectangles, and they are each represented with the fraction 6/8. So if I wanted to add all of these up, we could. Remember, denominator needs to be the same, so that's good. But then you don't add the denominator. You keep it there, and you simply add the numerator, 6, 12, 18. So I've got 24/8. How can I decompose that in different ways? Well, when you see the 24 and 8, you should be thinking of a multiplication fact. 8 times 3 makes 24. So actually, you could say 8 times 8 plus another 8. That would equal the same amount, the 24/8. Well, how would that work? Well, 8/8 is a whole. So what if I took these 2 8ths right here, and I put them right here. So I filled in this one and this one. Then what if I took these 2 8ths right here, and I put them right here. I filled in this one and this one. And I took these final 2 8ths, and I put them right here. And you see what I would have now is I would have my 3 8/8, and I would have eliminated this last one. So you can take this total quantity of 24/8, and you could break it down in a multitude of different ways to all represent the same amount.